Here we will take the special case of a pair of equations where the equations are in two variables but are not linear. Now you will encounter these types of equations in problems that deal with concepts of let's say time and work, boats and streams, and some problems of time, speed, distance, among other topics. Now let me show you some examples of such pair of equations. There you go. As you can see, these are not pairs of linear equations. However, notice the denominators in each pair. You will find a clue, I'm sure. I'll give you a couple of seconds to think about it. Did you notice something? Yes, we can use the method of substitution and convert these equations to pairs of linear equations. For example, let us take the first pair. The equations are 3 by x plus 2 by y equals 5 and 2 by x minus 1 by y equals minus 2. Let's call them equations 1 and 2. Now, what would happen if we assume 1 by x as p and 1 by y as q? Let's see. Now, equation 1 becomes 3p plus 2q equals 5. Now, this is a linear equation, and let's call this equation 3. Similarly, equation 2 becomes 2p minus q equals minus 2. Now, this is a linear equation as well. Let's call this equation 4. Now that we have a pair of linear equations in two variables, we can use any of the three methods, elimination, substitution, or cross multiplication, in order to solve these equations. Now let us use the process of elimination here. For this, we multiply equation 4 with 2 and we get 4p minus 2q equals minus 4. Let's call this equation 5. Now we add equations 3 and 5. There you go. 2q and 2q cancel out in both the equations and we are left with 7q equals 1. So q equals 1 by 7. Now we substitute this value of q in equation 4 and we get 2p equals minus 2 plus 1 by 7, or simply p equals minus 13 by 14. So what is the value of x? That's simple, 1 by p, or the reciprocal of minus 13 by 14, which is minus 14 by 13, right? Similarly, the value of y is 1 by q, or 1 over 1 by 7, or simply 7. So we now have our answer as x equals minus 14 by 13 and y equals 7. The trick here is just to reduce these equations to linear equations, and then you will find no problem. Before we begin this question, there's one important concept that we need to understand. Let's say I can finish a piece of work in 2 days. What does this mean? This means that in 1 day, I will finish 1 by 2 of the work, or 1/2 of the work. So in 2 days, I will complete 1 by 2 plus 1 by 2. That is 1 or the entire work. Okay? Now with this information in mind, let us attack the question. It is given to us that 2 men and 2 women can complete a piece of work in 3 days. Also, 2 men and 5 women can complete the same work in 2 days. Now we need to find in how many days can 1 man alone and 1 woman alone complete the same work. Okay? So let us take the number of days taken by 1 man alone to complete the work as x and the number of days taken by 1 woman alone as y. So what does this tell us? This means that 1 man can complete 1 by x work in 1 day, right? Similarly, 1 woman can complete 1 by y work in 1 day. So how much work can 2 men complete in 1 day? That's right, 1 by x plus 1 by x, or 2 by x. Similarly, in 1 day, 2 women can complete 2 by y of the work. Now, the first condition, what does that tell us? 2 men and 2 women complete the work in 3 days. So how much work do they do in one day? That's right, 1 by 3. And we can write a first equation as 2 by x, that is the work completed by 2 men in one day, plus 2 by y, that is the work completed by 2 women in one day, equals 1 by 3. That is the work completed by 2 men and 2 women together in one day. Let's call this equation 1. Now let's come to the second condition. 2 men and 5 women can complete the same work in 2 days. So what is the equation that we get from this? 2 by x, that is the amount of work completed by 2 men in one day, plus 5 by y, that is the amount of work completed by 5 women in one day, equals 1 by 2. That is the amount of work that they do together in one day, right? Let's call this equation 2. Now we need to solve equations 1 and 2. But we notice that these are not linear equations. So what do? That's right, we substitute. Let us take 1 by x as a and 1 by y as b. So equation 1 becomes 2a plus 2b equals 1 by 3. Let's cross multiply and we get 6a plus 6b equals 1. Let's call this equation 3. Similarly, equation 2 becomes 2a plus 5b equals 1 by 2. We again cross multiply and we get 4a plus 10b equals 1. And this is equation 4. Now we will use the process of elimination to solve these two equations. For this, let's multiply equation 3 by 2. And we have 12a plus 12b equals 2. This is equation 5. Now we shall make the coefficient of variable a equal. For this, we'll need to multiply equation 4 by 3, which gives us 12a plus 30b equals 3. This is equation 6. My word, so many equations. Now we subtract equation 5 from equation 6. There. And we are left with 18b equals 1. So what is b? That is 1 by 18. Now we substitute this value of b in equation 3. So we have 6a plus 6 into 1 by 18 equals 1, which gives us 6a plus 1 by 3 equals 1. We simplify this further, and in the end we get a equals 2 by 3 into 1 by 6 or 1 by 9. So what is the value of a? You remember a was 1 by x, but we also have a as 1 by 9. So that gives us x equals 9. Similarly, b equals 1 by y and b also equals 1 by 18. So y equals 18. And what was x? Therefore, one man alone will complete the work in x days or 9 days. And one woman alone will complete the work in y days or 18 days. And there, we have solved the question.